Morning. Welcome to BadTunnel, How Do I Get Big Brother Power in Mandalay Bay EF with Yang Yu, your speaker. Before we begin, a few brief notes. Stop by the business hall located in Bayside AB.
You want this?
The Black Hat Arsenal is on the Palm Foyer on level 3, and of course the Arsenal reception at 5 o'clock tonight. If you haven't picked up your merchandise, today is your last chance to visit the Black Hat Swag and Bookstore. Visit the Kali Linux Lab in Mandalay Bay, room A, which is just down the hallway. And please put your phone on vibrate. It makes it easier for the rest of us to ignore it ringing while you wait for your voicemail to pick it up. Without further ado, Yang Yu.
Thank you. Good morning, everyone. Thank you for coming to my talk. My name is Yang, and today I'm going to talk about BadTunnel. First, does anyone know about that giant circle? Yeah, Stargate. Are you a big fan? Good. Yeah. Just let me introduce myself. I'm from China, Beijing. I work for Tencent. You know, Tencent is a company, not 10 cents. Nobody works for 10 cents, okay? I'm running a security lab named Xuan Wu. That means the God of North, okay? And I got a lot of money from Microsoft, yeah? I'm working in information security industry from 2002. And before that, I'm a doctor. But now, I'm just you guys. Yeah. No girls anymore. First, I'm going to look at the background knowledge for the BadTunnel. Secondly, I'll tell you how to create a BadTunnel. Then I'll move on to what BadTunnel could do. Finally, I'll focus on how to defend against the BadTunnel attacks. See, the Lux Hotel fly up. Why I use this picture? Because I will talk about some really old stuff. The NetBIOS protocol. NetBIOS is an ancient protocol. How ancient is it? If you study on the history of NetBIOS security, you will see the name Cult of the Dead Cow. That's how old is it. It's like 1,000,000 years old. Yeah. The new generation may have never heard about this name. NetBIOS protocol is comprised of 3 sub-protocols. The name service, datagram service, and the session service. Most functionalities of NetBIOS are implemented in the session service. And the most vulnerabilities are also in name service, in the session service. But today we are talking about the name service. NetBIOS name service is a name resolution protocol, just like the DNS. Also, the packet is also like a DNS. It's just like a DNS running on port 137. But unlike DNS, it's not only listen on the 137, but also use the same port as the source port to send the packet. That is, the NBNS communication is from 137 to 137. That's the key. And the DNS transaction ID is randomized. But the transaction ID of the NBS protocol incremental. As we all know, the security of DNS is depend on the randomness of the source port and the transaction ID. But NBNS abandoned this in design. That's some kind of understandable, because the NBNS is designed for work in the local network, and it will send the packet to the broadcast. So all the hosts will receive this packet. Seems the randomized is meaningless. And there are actually two types of the NBNS packet. One is NB query, used in name resolution. I can work in both. It can work in both broadcast mode or unicast mode. It should be noted that in most cases we are only using NBNS to resolve host names, but it can also resolve FQDN. The system will first try to resolve the FQDN with DNS. If there is no result returned, the NBNS query is used. NB state query works in unicast mode. It usually used to diagnose the NetBIOS network issues. In most cases, the NB state query is sent by diagnostic tools like NB state. But the system itself will also send it when failed to access an UNC path. As we mentioned previously, the NBNS transaction ID is not random but incremental. And the NB query and the NB state query shares the same counter, the same transaction ID counter. That's another key. We can observe the two types of packet with a simple experiment. If we ping a host name, the system will send a NB query. If we query this IP address with NBT state, NB state query will send to this IP address. We can see this in Wireshark. And we can see that's the transaction ID, the NB query and the NB state query is incremental. That's the background knowledge we need to BadTunnel. Now let's see how to use this knowledge to actually create a BadTunnel. Alice, we use Alice and Bob. Alice is a typical internet user. She only has a LAN IP address and connected to the internet through a switch, router, NAT device, and firewalls. Bob is located outside of Alice's network. Alice can access Bob, but Bob cannot access Alice. If Alice sends a NB state query to Bob, which is an UDP packet with source port and destination port both set to 137, it can be received by, okay. It can be received by Bob. Yeah. After the packet passes through the NAT device, the source IP address will become the NAT's device IP address. Also, the port will be changed. But that's not a problem. The reply packet sent to Bob will also processed by the NAT device to make sure Alice can receive it. That is, after this communication is completed, no matter what kind of device is between Alice and Bob, there will be a tunnel created for both sides, UDP 137. Yeah, and whatever is a reply or a request. So we got the tunnel. Now the only question is how to make Alice to send an MB state query to Bob. Yeah. When Windows is trying to access an UDP an UNC path with IP address, if the 139 and 445 port of the target is inaccessible, the system will send a MB state query to the target IP address. There are two main ways to make a system access a UNC path. The Microsoft Edge and Internet Explorer both try to resolve the UNC path in the web page. And all types of Microsoft Office documents can have embedded the UNC path. The same is true for many other file types. If we have a shortcut with icon path point to a UNC path, the UNC path will be accessed even the shortcut is just shown on the screen. We may even create a BadTunnel on a web server or a SQL server. Two main ways. That because the UNC is a part of Windows, right? You can't just get rid of it. When we create a BadTunnel and can access MBNS service to another system, what can we do next? Play golf? We can hijack any host name, like WPAD. About WPAD, there's another talk this afternoon about WPAD. Yeah. WPAD is a web proxy auto-discovery protocol. Windows systems use this to configure proxy settings from Windows 19.5. Yeah. If we hijack the WPAD host name, we can control almost all of the TCP and UDP traffics. The problem listed on this page are mostly known issues, and they look very serious, but nobody fixed them because they all have to be done in the same network. Now, BadTunnel can let us do this attack anywhere in the world. Let's see a complete attack to hijack WPAD. First, Bob induced Alice to access a malicious URL or file or anything. In the web page, there are two embedded paths. One points to Bob's UNC path, and another is a WPAD path. After Alice accessed Bob's UNC path, the system will try to access Bob's 139 and 445 port. Accessing WPAD path will broadcast a NB query. But Bob cannot reply this for now. If Bob denied Alice's access to his port, Alice will send an NB state query to Bob. This will open up a double direction tunnel, as we say, and leak the current transaction ID counter. One stone, two birds. Bob can now use leaked transaction ID to craft a valid NB response and send it through the tunnel to complete a cross-network NB spoofing. With BadTunnel, you can hijack the network traffic of every version of Microsoft Windows, going back to the Windows 95. And this is big broad power. Now let's discuss how to defend against this attack. I have reported this vulnerability to Microsoft in March, and they have fixed it in June. That is pretty quick. For fixing this level of vulnerability. How they fixed it? There is no more NB state query after failed UNC access now. And no longer use NBNS to resolve WPAD path after you install that June patch. If you are still using unsupported Windows, like Windows XP, or otherwise cannot install the patch, you could consider disabling the netbox over TCP/IP. It's also a good idea to block port 137 on the border firewall. Your network administrator may have done this in 2003. Remember Blastworm? Another Asian thing. You remember that Blastworm? Don't pretending teenagers. We're all old guys. Although this is useless against the Blastworm, but many network administrators do that. People were scared at that time in 2003. But this is really an effective way to prevent BadTunnel attacks now. Okay. That's all. I still have a few minutes. And I really made a huge mistake. Just apply for 25 minutes briefing things. I should apply for 40. So I think you may have a lot of questions. Please see the white paper on the Black Hat website later, or you can ask me now. Any question? Okay. When? You mean when or why? Why? When? This year, March. Yeah. Oh, that's even not a question. Okay. Another question? If there are no question, I'll show you some demo. Guys, I will play the demo. Don't go. Don't go. Still not finished. Your lows. This is Bob. We can see this is the IP address of Bob. This is Alice. We can see they are in different network. And Alice can access Bob. Bob can't access Alice. Okay, this is a simple web server. This is the BadTunnel. This is the BadTunnel application. We can see the, the netbox cache table is only an OA. There's no WPAD on Alice. See, on the Alice, we access the web page on Bob. We trigger the BadTunnel and send the spoofing packet. Now, we return to Alice to see. The WPAD name is hijacked. Okay, thank you.